Start in about 1 minute. 1 minute. All right, here we go. This is a fun class. Test, if you turn it in, I'm working my way. Almost all of my tests, I'm looking at Avery. What is she saying? Give me 1 second. Look. Okay, back to this. Test grading, all my classes had tests yesterday, so it's going to take a while. Also, because some kids are watching this a day behind. Some have turned it in, some have not. So if you're watching this live, I know Prudence is here. So you turned yours in, then I'll have it graded. If not, then it might be a day that after you watch this video that yours will be graded. But rest assured, I will have all your stuff graded. Looking at the test, pretty good. I didn't see anything that really scares me. You guys did fine on it. All right. Oh, why does that say 7-2? That should say 7-1. Let me change that real quick here. Yeah, we were on 7-1. We are not on 7-2. There we go. Now it's correct. All right, we're on 7-1. We'll do 7-1 today, 7-2 tomorrow. The only homework over the holidays will be just the homework from 7-2. You could probably knock that out on Friday as well too, so you will have no homework if you choose to do that. If not, you got one homework assignment as always for that Friday. We'll come back. We'll do a review because you guys will probably have forgotten some of this stuff, so we'll review it real quick and then we'll move on. Chapter 7 will be the last chapter before Christmas break. We'll do a review and then we'll take semester finals. The last 3 days of the semester, that'll be Wednesday, Thursday, Friday of that week right before Christmas, will be semester finals. You'll come in, you'll take about 2 tests. You'll probably take one. It'll be a long test, by the way. It's going to be a semester final, so everything you learned in that class. Not all your classes are doing semester finals, but clearly your core classes in Latin will. It'll be a semester final. More to follow on that as we get closer, but the general scheme maneuver for that is you take test 1, then maybe you go to student advisement for, half hour to an hour for a study break, and then right into test 2, and then you go home. All right. Here's your homework for tonight. 2 parts to it: written exercises and problems. Problems are word problems. So on 232 to 233, written exercises 1 through 20, all of these are quickly done. Word problems are also fairly quickly done. Good to see you, Landon.
Good to see you too.
Make sure, hopefully you read and understood my note from last night.
Mm-hmm.
Okay. Let's see, I remember I graded Lucia's. I can't remember. She's the only one I remember grade. Maybe because it was one of the last ones I graded last night before I went to bed. But if you guys turn in your homework, I know I graded Landon. I talked to him about it. Okay, here we go. Ratios and proportions. Ratios and proportions. 3 objectives here. You're going to have to write ratio. You're going to have to determine if something forms a proportion. And lastly, determine unknown values in a proportion. I know we did this in course 1. Jace is the only one that I didn't have in course 1. Hopefully you had course 1, so you remember this from last year. So first thing is in your notes, put this definition. A ratio, R-A-T-I-O, ratio, is a comparison of two numbers using division. I'm going to compare two numbers using division. Pretty simple definition. So how do you compare two numbers division? Well, I could use the division symbol, but I can also use a fraction bar, and a fraction bar means division. So let's say, for instance, I had 4 blue dots and I had 6 red dots. If I wanted to compare those two numbers using division, it turns out there are 3 methods to show that. Well, the first one is called fraction form, because it uses a fraction. So 4 compared to 6, the fraction bar means division. The second method of writing a ratio is called what's called colon form. Literally, the grammar usage of the colon we also use in math. So we'll do the same thing. We'll compare 4 to 6 using a colon. There we go. And then the last method is to use English words, and we will use the word TO2. And you've probably heard this. This is called word form, and it's called 4 to, not the TWO, but TO, 4 to 6. Now, how did I know that 4 was the first one and 6 was the second one? Yeah, that's what's got to be spelled out when you're asked to create the ratio. For instance, I would have to specifically tell you, compare the blue dots to the red dots. That would be 4 to 6. If I can ask you to compare the red dots to the blue dots, that would be 6 to 4. So we got fraction form, colon form, and word form. All of those mean the same. Why do we need 3 to do one thing? Generally speaking, the last 2 are simply used to show a ratio. Fraction form is when you're actually doing a fraction and you need to use that number mathematically in a specific operation: add, subtract, multiply, or divide. Although you can use the second 2, it's just more convenient to write in fraction form when you're doing some math. All right, we good on just the definition of ratio? Okay. Quick note, 4 to 6 is not reduced if it's in fraction form, so you can reduce that to 2/3. And by the way, 4 to 6 is the same as 2 to 3 as a ratio. Okay. Do you have to reduce a fraction? I'll go back to this. If I'm literally comparing 4 dots to 6, if I'm literally comparing 4 dots to 6 dots, I kind of would like to not reduce it so I can see that I initially had 4 blue dots and 6 red dots. However, if you convert that to 2 to 3, well, it's still numerically, or value-wise, you should say, it's still value-wise the same ratio. 2 to 3 is the same as 4 to 6. However, you lose something when you do that reduction. If we reduce all of this to 2 to 3, then you never know how many dots we actually started with, and that could be important. All right, so that was the quick note. But you can reduce ratios, whether they're in fraction form or colon form or word form. All right. Another quick note is that we can have improper fractions. If we had 7 blue dots to 4 red dots, oh, that's perfectly fine. The one that we will not have is a mixed number. So if we have a mixed number, we'll just convert it to an improper fraction. All right. All right, ratios, we use ratios in the real world to describe those relationships between the quantities. So I'm going to give you 2 quantities, and the ratio describes what's going on. So here's an example. So an airport runway is 120 meters wide and 5 kilometers long. Use a ratio to compare its length to its width. Okay, so a lot going on here. Well, first off, we can see we're dealing with the metric system. Secondly, it says to make a ratio. And thirdly, it will tell us specifically how to make this ratio. It tells us to make the ratio of its length to its width. Now, we need to find the word length and width, but you know, they're using some conjugation going on here. So instead of word, they have wide. Instead of length, they have long here. So hopefully you know that length and long go together and width and wide go together. But there's another problem here. Notice I have 2 dissimilar units. I've got meters and I have kilometers. Okay, both of those describe length, right? Or describe a distance. I didn't want to say length, I wanted to say distance. Both of those describe a distance, right? And both of those are part of the metric system. And distance measures how far it is from one point to a second point. So when that is the case, we must ensure that our units are the same. All right. I'm asking you to remember something I taught you last year. Who remembers how to convert? Who remembers how to convert metric? Anybody remember the saying that we learned last year? Now, Lucia I didn't teach, but nor Jace. But the rest of you I taught. You guys remember the saying to convert metric?
King Henry died by drinking chocolate.
There you go. King Henry died while or by, B for base, drinking chocolate milk. Now, K stands for kilo, M stands for milli. It's the B that gives us the problem. The B stands for meters, liters, and grams. So we need to convert either meters to kilometers or kilometers to meters. It doesn't matter. I'm usually a big proponent of changing from the larger to the smaller. Why did I say that? I'm more of a proponent to convert the larger to the smaller. There we go. Boy, did I mess that one up. So I would convert kilometers to meters. So remember, if you're going from K to meter, remember B stands for meters, liters, or grams. Meters, liters, I cannot write with a mouse, or grams. Okay, so we're going from K to B. That's 1, 2, 3 to the right. So I would take 5, because I'm converting kilometers to meters, and I need to move the decimal place 1 letter, 2 letter, 3 letters to the right. That's the same as moving it 3 decimal places to the right. Now, there's only a few of them tonight for homework where you have to do this one. But let's see, 5 kilometers is 5,000 meters. All right, so now I can do length to width. So let's see, I need a fraction or colon form. Either one's fine. So length is not 5 kilometers now, it's 5,000. Where did I get the 5,000 from? From that metric conversion. So 5,000 meters to 120 meters wide. And there's your ratio. Or I could write 5,000 colon form to 120. Either that one will be perfectly fine or this one will be perfectly fine. Do you guys want to reduce the fraction or you want to leave it alone?
Reduce.
Okay, so generally speaking, there's no hard fast rule here. If you're trying to just compare, hey, is it wider than it is long, right? Maybe it would make sense to reduce the fraction. If you simply want to compare the two numbers using division and you want a general sense of the actual values, don't reduce it. Leave it as 5,000 to 120. However, if you want a sense of just its general proportions, I'm going to use that word proportions there, then we would reduce. And I realize that that's not a very pleasant answer of when should I do it and when should I not. I'll just say there is no time in this chapter where if you're talking about ratios or proportions that it will be required that, or I should say ratios, that will be required that you reduce. So this gives you a general idea that it's 125 times long to 3 times wide, and that gives you a better sense of what the relationship between length and width are. Okay, and remember, this could be in fraction form or it could be in colon form. Questions on what I just did? I started off with the hardest one with a metric conversion. All right, other times that the units will be completely dissimilar to each other, and you'll see one here, right here. Now we're going to convert Roger's car traveled 120 miles on 9 gallons of gas. Express the ratio of miles per gallon in lowest terms. So this one is asking us to reduce the fraction here in lowest terms. But I will say, I'll point this out really quickly, is that if we compare miles to gallons, those are 2 dissimilar units of measurement. One measures distance and one measures liquid volume, right? Therefore, you can't convert miles to gallons or gallons to miles. So we don't have to do any conversion here. We just simply need to set up the ratio. And this one does tell us right here it wants it fully reduced, okay? So let's see, how does it want to do? It wants us to do miles per gallon. Per is a fancy word for fraction bar, right, or division. So we do miles, that would be 120 as the numerator, and the denominator is 9, and then it wants us to reduce that. That could be reduced by what number? What goes into 120 and 9?
3.
Remember the rule of 3. 3 says add up all the digits. 1 plus 2 plus 0 is 3. 3 goes into 3. So 3 goes into both. So that would give me 40 over 3. So that is the ratio of miles per gallon. I get 40 miles for every 3 gallons of gas that I use. And if you want in colon form, I don't have my book open, so I can't tell whether it says to write it in fraction or colon or both. If it doesn't tell you specifically, then it's up to you to decide how you want to write it. All right, I'll give you guys got about a 20-second head start on both of these, or I'll give you a 30-second head start on both of these. See if you can do both of these all by yourself. All right, first one, you buy 4 paints of cans to cover 110 square feet of wall space. What's the ratio of square feet to cans? So square feet's on the top, cans are on the bottom. How many square feet we have? 110. How many cans we have? 4. If we choose to reduce this, I'm going to divide both by 2. I got 55 to 2. So 55 square feet to every 2 cans. And that would be the ratio. In colon form, that would be 55 to 2. Second one, the recipe calls for 6 eggs and 8 cups of flour. I have no idea what you're making with that many eggs and flour. That's a lot of cups of flour. What is the, maybe you're making, let's see, what do you, I have no idea. There's no sugar in there, so you're certainly not making cookies. The recipe calls for 6 eggs and 8 cups of flour. What's the ratio of flour to eggs? So flour on the top, eggs on the bottom. How much flour? 8. And how many eggs? 6. So 8 to 6. We would reduce that, divide both top and bottom by 2. That would be 4 to 3. 4 to 3. Any problems with either one of those? And yes, they will be that easy tonight for homework. The big question is, well, how do you know when you have to change the units to the same? Notice on both of these scenarios, we've got square feet. That's a measurement of area. In cans, that's a measurement of liquid volume there. So you can't convert square feet to volume. You also can't convert eggs to flour, right? So there's no conversion there. The ones that will be obvious, generally speaking, are when the units are exactly the same. You're really dealing with distances or liquid measurements or something like that. And then only if they give you things like, the metric system. All right, 2 more. Once again, I'll give you a 30-second head start. Ooh, the second one you need to convert. It's dealing with distance, and we have yards and feet. There are 3 feet in every yard. 3 feet in every yard. Hint. All right, the first one, you drive 10 hours and you go 325 miles. What is your speed in miles per hour? Speed is a ratio. It's a ratio of how far do you go versus how long it took you to go that far. So miles per hour, miles on the top, hours on the bottom. Miles is 325, hours is 10, so 325 over 10. 5 would go into both of this, so 65 over 2. 65 over 2 or 65 colon 2. The second one, notice this is an example of where we have both measurements are using the same thing. It's a measurement of distance. One's in yards, one's in feet. You can either convert yards to feet or feet to yards, okay? I don't care how you do this particular one. I'll just change yards because it's a nice friendlier number, 100. And I know that there's 3 feet in every yard, so that would be 300 feet. By the way, 100 yards football field, 100 yards, 300 feet. So this would be 300 feet. Now it wants us to convert or write the ratio of length to width. Length is the word long, width is the word wide. So 300 feet to 156 because I converted yards to feet. Now, if you did it the other way around, let's see if we can do that math real quick. If we do it the other way around, you got to convert feet to yards. There's 3 feet for every yard. So if we divide 156 by 3, we would get, what, 52. So that would be 52 yards is 156 feet. Okay. So if we wrote that one, it would be a different one. We would get 100 over 52. And that would be in yards. Notice 2 completely different answers expressing exactly the same thing. So reducing the bottom one, let's see, we can reduce that by 2, I don't know, let's see. Do it a bunch of times. That's 6 and 12. Yeah, reducing it by 2, we get 150 over 78. Reduce it by 2 again, it'd be 75 over 39. Does 3 go in that? 12. Yeah, 3 goes into both of these. 3 goes into 75 25 times. 3 goes into 39 13 times. So 25 over 13. If we reduce the top one, let's see, those are both, 4 goes into both of these. So that would be 25. 4 goes into 52. 1, oh, it goes 13. Oh, it's literally the same thing. Whether you changed it from yards to feet or feet to yards, you wind up with the same ratio. That's kind of crazy there, right? However, you do need to make sure that in your answer you would be telling the reader what they have. Okay. All right, questions on that? Okay. All right, so that's the easy part. Just simply write a ratio from a scenario. They'll tell you the scenario. There's a couple of those tonight for homework. The second part is also fairly easy if you're quick with your math facts. We will be doing proportions. By the way, we spent an entire chapter on this last year. Now we're going to get 1 class on it. Figure that. All right, write this in your notes. Proportion. A proportion is a statement that indicates that 2 ratios are equal. A proportion is a statement that indicates that 2 ratios are equal. When you have a proportion, you will have an equal sign somewhere. You will have an equal sign and you will have 2 ratios, right? So in other words, you're going to have 2 fractions or 2 colon forms with an equal in between them. They're not going to give you this in word form. So 4 over 6 is equal to 2 over 3. Well, we can kind of see that. If you reduce 4 to 6, you get 2/3. 2 ratios with an equal sign in between them. Now we must make this more challenging than this. So 8th grade is when we introduce you to 2 brand new terms. Boy, did these 2 terms give me problems when I first learned this. I think it was because my teacher didn't do a good job of explanation. So I will try to do a better job than my teacher did for me. This idea of proportion is no big deal. I mean, I understood that thing. It was the very next thing. They used these new special words to describe both of these fractions, and it kind of went over my head and I didn't understand it. So I'm going to try to do it nice and slowly and explain it well for you. So here we go. Oh, by the way, 4 is to 6 is 2 is to 3. All right. So for any proportion, it turns out, and hopefully you remember this from last year, that their cross products, right, 4 times 3 is the same as 6 times 2. And if we just left it as that, right, everyone will be okay because everybody can see that for proportions. The bigger question is why. I'll try to do that real quickly for you. Why is this the case? Well, if instead of numbers, we just put variables, if A over B is equal to C over D, and we do a little bit of algebra, I'm going to choose to multiply both sides by BD. Now, where did I get the BD from? Remember, I'm allowed in math, in algebra, to multiply anything to both sides as long as I do it to both sides. So I'm going to choose to multiply both sides by BD. You'll see why here in a second. If we look at what we have here, let's see, on the left side, the B's would cancel. And on the right side, the D's would cancel. And we would be left with that A, I want to choose to write this as A times D is equal to C times B. And that's exactly what we have here. A times D is equal to C times B. And that's what allows me to make that statement right there. All right, that's called a proof. All right, so we get 12 is equal to 12, and this is now the only challenging part. All right, so I need you to write this down. This will be used in higher level math, these words, these terms, but it's first introduced in 8th grade when we talk about proportions. So this idea of cross products, that this number times this number is equal to this number times this number, is very easy to see in this example. Most students, when I show you this next slide, will say, well, why do you make it so complicated? It's because we will use this concept later on in other levels of math. So I want you to write this down in your notes. We're going to call the top one on the left an extreme and the bottom one on the right an extreme. And we're going to call the bottom one on the left and the top one on the right a mean. And this is why when you are first taught this in proportions, you always get this statement that in any proportion, the product of the means, that just means this number times this number, is equal to the product of the extremes. I'm not sure why that's blue there. It meant to be red. The product of the means is equal to the product of the extremes. And I remember my teacher telling me this many times. I just didn't really understand what this meant. Well, it meant this right here. What I got lost on was, why are these two called the means and these two are called the extremes? I got cross product, right? The cross multiplication made sense to me, but I didn't understand why these were called the means and these were called the extremes. And for some reason, my math teacher never wrote both of these in colon form. Well, let's write both of these in colon form. If we write this first ratio in colon form, we would get extreme colon mean. And on the second one, we would get mean colon extreme. And now you can kind of see why literally they're called the extremes, because they are the numbers that are on the outside in colon form. The outside are called the extremes and the insides are called the means. And if you remember, mean it describes the middle, right? This is why it's called the product of the extremes is equal to the product of the means, or vice versa. The product of the means is equal to the product of the extremes. So yes, we are trying to make it slightly more complicated, not because we're actually trying to make it more complicated, but we will use this later on in math. They choose in 8th grade to introduce you to this concept as that cross product or cross multiplication. We're going to describe it as the product of the means is equal to the product of the extremes. Are you going to need to remember that this year? The answer is no. What you're going to be asked to remember is that cross multiplication works, and you're going to be asked to do cross multiplication. But I do have to introduce this to you this year. So product of the means is equal to the product of extremes. All it is a way of just simply saying that cross multiplication works. All right. So we're going to play two new games. The first one is it a proportion? I'm going to give you two ratios with an equal sign and a question mark. And the question mark is asking, are these two ratios equal to each other? In other words, I would prefer if they were to erase the equal sign and just put an equal sign and say, can I replace the equal sign with a question, or replace the question mark with an equal sign? They choose not to do this. They choose to write it in this manner, but it's okay. So we're just going to see if the left side ratio is equal to the right side ratio. It's easily done with some cross multiplication. So if it is a proportion, then we know that the product of the means is equal to the product of the extremes. In other words, we know that 4 times 12 should equal 6 times 9. Well, let's see if that mathematically is true. Remember, we don't know if this is a proportion. If it is a proportion, this must be true. So 4 times 12 should equal 6 times 9. 4 times 12 is 48. 6 times 9 is, wait a minute, 6 times 9 is not 48, it's 54. So in other words, this is not a proportion. Why? Because the product of the means, that's 4 times, the product of the means didn't equal the product of the extremes. So the means were 6 times 9 and the extremes were 4 times 12. All right, so what are you going to be asked to do tonight for homework? You're simply going to ask to do some cross multiplication and see if it's true or false. If it's true, then you can say, yes, it is a proportion. If it's false, like it was in this case, then it's no, it's not a proportion. Let's see that again. Here are 2 ratios. Let's see if they, in fact, form a proportion. If they form a proportion, the product of the means will be equal to the product of the extremes. Now, I'll just say here's another reason why I never understood product of the means, product of extremes. Because when you think about this, because, I don't know, maybe we read from left to right, top to bottom, I always thought 9 times 20 was the means. It's not. 15 times 12 is the mean. 9 times 20 is the extremes. Maybe that's why I was confused as well, too. But I could certainly do cross multiplication. Let's see, 9 times 20 is 180. Well, I'm not sure if 180 is equal to 15 times 12, so maybe you might have to do a little bit of scratch work. So let's see, 12 times 15, if that equals 180, then we're good to go. 5 times 12 is 10, carry your 1, that gives me a 6, bring down my 0, that gives me a 2, yeah, that equals 180. So therefore, yes, that does work, okay? So a little bit of work, but not too much. So this one's a big fat yes. Questions on what I just did? Stop me if I'm talking too fast. All right, you have 2 of them in front of you. This is what homework will look like tonight. They will give you 2 ratios with an equal sign and a question mark, and they're asking, are those 2 ratios proportional? In other words, do the product of the means equal the product of the extremes? So go ahead and give you a 30-second head start, and then I'll work these out. All right, let's see. The first one, 7 times 10 is 70. 5 times 12 is 12, 24, 36, 48, 60. And 60 doesn't equal 70. Therefore, the first one is no, it is not a proportion. The second one, let's see, 8 times 9 is 72. 4 times 18, 4 times 8 is 32. 2 carry your 3. 4 times 1 is 4, plus 3 is 72. Oh, yeah. I get 72 on both sides, so the second one is a proportion. Questions what I did or questions on the work? Questions on how to determine if 2 ratios form a proportion? Silence from the crowd. Okay, well, that clearly means that you were good to go. Moving on. Last thing. Hey, this is going pretty quick. It's the same drill, except this time, the so what about this is that you can determine if one of these numbers is unknown, what it is. Well, let me explain how this would work. We know that if you have 2 ratios and they are equal to each other, that their cross products must be equal. In other words, we could solve this algebraically. Watch what I do. The product of the means has to equal the product of the extremes. So 15 times 6 must equal, if it's a proportion, m times 20. So we can literally just set that up as an algebra problem. So 15 times 6 must equal 20 times m. I'm just going to write that out. 15 times 6 is equal to 20 times m. All right, well, I do need to do a little bit of scratch work. It turns out that 15 times 6 is 240. Now it's just a one-step equation. I need to get rid of the 20. It's attached by multiplication, so we simply divide both sides by 20. The 20s cancel out, and you should be able to do this in your head. 240 divided by 20 is 12. Who's lost? All I did, if they are a proportion, is the product of the means, 15 times 6, must be equal to the product of the extremes, 20 times m. I simply do that math and then solve the equation. Pretty simple. Let's do one. Write this one down. 42 over 14 equals 18 over C. We will use the logic of if you have a proportion, the product of the means, that would be 14 times 18 will be equal to the product of the extremes, 42 times C. So we set the problem up, and we do the math. Oh boy, we need to do some scratch work. So let's see, 14 times 18. 8 times 4 is 32, carrier 3. 8 times 1 is 8, plus 3 is 11. Bring down the 0, 4, 1. I'm getting, I sure hope that was a 1. My handwriting with a mouse is pretty bad. I got 252. Yep, that's right. Oh, why couldn't they give us easy numbers? All right, 252 divided by 42. Yeah, we have to do some scratch work. So let's see, 252. We could take a guess and assume that it's going to be a nice, friendly answer. Let's see. This is about 40. 40 goes into 250 about, what, 6 times? Something like that. So my guess is 6. 6 times 2 is 12. Carrier 1. 6 times 4, 24. Oh, yeah. I made a good guess. There we go. All right. So you can reduce that if you'd like, right? As I did right there, or you could do the long division and see what you get. Tonight for homework, and as we move higher into Algebra 1, we are very comfortable with leaving things in fraction form. In other words, well, let's just say that if 252 was not divisible by 42, we would reduce the fraction. Okay? In this case, we reduced the fraction and it turned into a whole number, 6. Questions on what I just did? Nope. All right. There's one in front of you. Go ahead and do that one. I'll give you a 30-second head start. All right, let's see. The product, if it's a proportion, the product of the means, that would be 3 times 14 is equal to the product of the extremes. That would be 4x. So I get 4x is equal to 3 times 14. 3 times 14 is 42. Does 4 go into 42? It does not evenly, so it's going to be a fraction that's reduced. So let's see. We divide 42 by 4. Let's see, 2 goes into both. I'm going to get 21 over 2. 21 over 2. If you really wanted to write it differently, you could write it as a mixed number. I'm perfectly okay with 21 over 2, though. You never have to change an improper fraction to a mixed number unless it specifically says to. All right, everybody good on this? Not too challenging, right? When would I ever use this? Well, we could use it in a real world problem. I gave you 4 of these tonight for homework. Watch how we do this. You guys ever seen them make cement before, right? You take, or concrete before, you take bags of cement, right? You put it in one of these mixer things here. You put in some rocks. You put in a little bit of water. You mix it all together, and you make concrete. All right. All right, the directions on the bag of concrete mix call for the addition of 3 gallons of water for every 40 pounds of mix. Now it says, well, how much water will you add to 30 pounds of the mix? This is a pretty useful thing. So for instance, if you used a little bit of the bag, 10 pounds of it for something, and you only have 30 pounds, but the packaging material says 3 gallons for the whole thing, well, how much water you need? You got to figure that out because you only have 30 pounds now. Well, this is pretty easy to do if you set this up as a proportion. So let's see, the proportion, how much water, that's what we're trying to solve for if we have 30 pounds. So if we have 3 gallons of water for every 40 pounds of mix, that would be a ratio of water to mix. And it doesn't matter whether you do water to mix or mix to water, as long as you follow this pattern. We do water to mix, that would be 3 gallons for 40 pounds, so 3 to 40. That's the ratio of water to mix. Well, our new mix, we don't know how much water we should add, so that's going to be our X. But we do know how much mix we have. We have 30, all right? So there is my proportion. I solved this proportion, and like magic, we figured out how much water. And this is a very useful skill, okay? 3 times 30, that's the extremes here, would be 90, and then the means would be 40x. Divide both sides by 40, reduce each by 10, and we would get what? 9 over 4, and that would be 2 1/4 gallons if I convert that. Let me show you the math behind that. So let's see, if I reduce that fraction right there, that will give me 9 over 2. 2 goes into 9 4 times, with 2 goes into 9 4 times with a half. Why does that say? That is clearly wrong. That's weird. Boy, I messed that one up. Okay, why has this not been caught? Why has it taken 3 years for us to catch that mistake? That's crazy. That's crazy. Or wait, let me do this one again. Did I just make a second mistake here? Let's see. 90 would be 9 over 4. No, I did a mistake there. Sorry, 9 over 4. I put 9 over 2. All right, I didn't make a mistake. I was correct. 4 goes into 9 2 times with 1 left. All right, I had it right. That's why no one caught it, because it was correct. All right, so 2 1/4 gallons. And there's a perfect example of why you'd want to convert something to a mixed number. If we left it as an improper fraction, this is how much water you need, 9 over 4. Well, how much is that? I don't know, but I do know how to measure 2 1/4 gallons, right? That would be easy to measure. All right, questions on that? All right, let's see another one. If you know what you're doing, go ahead and try this one. Oh, by the way, paint is expensive. I made this class, I think, about 3 years ago. And a gallon, right? A gallon of paint costs $32, almost 33. That's crazy, right? 33 bucks for a gallon. So it turns out that 5 of these cans will cover 130 square feet of wall space. How many cans will be needed? Well, my room is bigger. It's 208 square feet. So when you're looking to see, how many cans of paint you need to buy, this is the kind of math that you'll have to do. And everybody paints rooms. The person that does bad math simply buys 1 can. They start painting the room and find out, oh, I don't have enough paint. They go back to the store. The smart person does the math and figures out how many cans of paint they need. Okay. All right. So let's see if we can set up this proportion. So for 130 square feet of wall space, it takes 5 cans. So if we do cans to area, if we do cans to area, right, that would be 5 to 130. We need to cover 208 square feet. So what we don't know is how many cans that will take. So the cans would be the X, and 208 would be the square feet. Okay, the math here isn't friendly because it's a real world problem, but it's easy to understand what to do. Remember the product of the means, that would be 130x is equal to the product of the extremes, 5 times 208. 5 times 2, so 5 times 8 is 40, carry your 4, 5 times 0 is, that's 48, and 1,040, okay? 1,040. 5 times 8 is 40, carry your 4, 5 times 0 is 0, plus 4 is 4, 5 times 2 is 10. There we go. So we need to divide that by 130. Oh, why can't they make my life easy? Well, that's because it's a real world problem. So let's see if we can do this. So that would be 1040, all divided by 130. Well, clearly we can reduce that by 10 right from the very start. So that would give me 104 over 13. Does anything go into that? 1 plus 3 is 4. 3 doesn't go into that. Yeah, we're kind of stuck with that. So we got to do that long division right there. We got to divide 30 because we got to buy how many cans? We got to buy 104 over 13 cans of paint. How many is that? Well, let's see. How many times does 13 go into 104? 104 divided by 13. 13 is close to 10, right? 10 times 10 is 104, but it's 13, so it's not going to be 10. Maybe it's 9 or 8, right? I'm kind of going, or maybe 7. I'm kind of going with maybe 7, right? Let's see. 7 times 3 is 21. Carry my 2. 7 times 1 is 7 plus 2 is 9. So we get 91. And we do our subtraction, we get a 3. And we get a third. Oh, it actually goes 8 times. Oh, I guess too low. 8 times 3 is 24. Carry your 2. 8 times 1 plus, oh, it worked perfectly, right? So remainder is 0. So it was 8 cans. 8 cans of paint, right? That was pretty cool. So now I can go to the store and buy it perfectly, how much paint I need, right? Rather than going to the store 4 times, right? Questions on what I just did? 8 cans of paint. 8 cans of paint. All right. That was it for today. Those last ones, 1 through 4, are problems. I tried to choose 1 or 2 of them that were like the ones for homework to give you a little bit of help on that. But 1 through 20 are all pretty similar. It's just basically make a ratio and then do 2 numbers form a proportion. And then the last one was they'll erase one of the numbers and have you solve for it, just like we just did. Any questions? Okay, that's where we'll end then right there. If you do run into any problems, remember I'll be by my computer until at least 8 o'clock tonight. Send me a quick chat and I'll be happy to help you out. Then I will catch you guys tomorrow. See you tomorrow. Remember tomorrow's Friday, so it's Friday schedule. So we do the assembly first, 8 to 8:30-ish. So class starts tomorrow. Period 3 is 9:59. 9:59. All right, see you tomorrow, 9:59.